Hello, everyone. Thank you for joining us for our next Learn Live, Orchestrate Multi-Agent Solutions using Semantic Kernel. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our moderators to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor YouTube channel. With that, I'd love to introduce our presenters for today. Thanks for joining.
Hello, everyone, and welcome to this lovely session on live Orchestrate multi-agent solutions using Semantic Kernel. My name is Corey Stiggerad-Pace, and I want to go ahead, before we go, welcoming everyone, thank you for coming. This slide, Shivam, this is our fault because it's out of date. I am a senior cloud advocate here at Microsoft, and Shivam, I'm going to put you on the spot. I want to take your intro, but I want to say one thing to the audience out there. Shivam has just joined us as an AI MVP. MVPs, if you don't know at Microsoft, are basically community leaders who are contributing so much to the community in the world of Azure, world of AI. And Shivam was recently awarded that. So if you could do in the chat, I know we have a lot of people, but if there's at least one person watching to say congrats to you, Shivam, on your nomination as an AI MVP. And I know I stole some of your introduction, but welcome as well.
Thank you so much. Thank you, Corey and Lee as well.
Yeah, so, well deserved.
Let's switch to another slide.
Let's do it. So this is a Learn Live session. As the name implies, we're going to be doing learning. We're going to focus on this Learn module, which is the multi-agent semantic kernel. You can go into that link there to follow along, or you can watch us complete it, go through the content, and then obviously that's going to be available for you. I'd love to see all the congrats in the chat as well. Hopefully, Shivam, you're seeing that.
Thank you, everyone. Thank you, everyone.
Awesome. Next slide. So in the chat as well, so we're gonna, I do these live streams and I love it because then it's kind of me talking to you, talking to me through the chat. But sometimes I get caught up in actually delivering the content, which is probably why I'm here and not just looking at the chat. So we have these lovely group of moderators in the chat now that will help you answer any questions that you have about this module, about semantic kernel and building with multi-agent solutions. And if we have time at the end, we'll kind of save some time to answer any questions that they see and that you want to bring up to us, so we can answer that for everything there. But yes, shout out to our awesome moderators. And this is a slide that says say hi and ask questions in the chat. I think I covered most of that. I see you all saying hi now, which is great, and also saying congrats to Shivam, which is the theme of today, as well as building multi-agents. So cool. Next slide, Shivam. And your part, you might have joined us today just for this session, just to say congrats to Shivam. I don't know why you've come, just to learn about multi-agents, but this is actually part of a bigger fest, if you will. It's called the Microsoft AI Skills Fest. It's been going on for some time now. It's actually going to finish up at the end of this month, but we have many different sessions covering AI. So even if this is your first session joining us, you can look at that link there, and you will find out all the other sessions from our Learn Lives, because there's some quality content that's been delivered over this time. But an agenda today. So, we're going to really focus on a few different areas. First is an introduction, understanding, what exactly AI agents are. In case, this is your first kind of session on that topic. We're going to also look at understanding a semantic kernel. This is like the agentic framework we're going to be using and developing on. So it's kind of a good idea to get some, background on that. The next thing we're going to do is what we call a selection strategy. I don't want to give any spoilers out, but this is kind of when we're working with multi-agents, we need to select which agent, right, that we want to complete the task, and we're going to look at that later on. And then termination, because a lot of times when we talk about multi-agents, people ask like, but when does it end? Do they just keep chatting along with each other? And that's going to be really costly. So we're going to look at the termination strategy built into semantic kernel. So these are two semantic kernel features that are kind of applying good agentic design patterns on there. And then we're going to get hands-on and look at the exercise of this module, look at the code, how it works, how it's kind of applying those two different topics. And then lastly, we're going to play a little game. Stephen and I, we're gonna quiz each other on this module and these questions, and we'll hopefully see your answers actually on the chat as well, going on there, and then we'll wrap up. How does that sound to you, Shivam?
Yeah, absolutely fine.
Perfect.
And exacting also, let's see how many of the people will answer correctly.
I think all of them. I have faith in this audience.
Yeah.
We'll see. Perfect. So we'll start with a bit of an introduction. So when we talk about agents, right, one of the biggest things is it's kind of specific task that we have working with agents. Like, right, we want to make sure that, just when they're just having, large language models, they're good at answering questions, retrieving information. But in this scenario, what we're building out now, it's basically going to be solving an IT issue that we all have. Either if you've worked in development, worked in software, things tend to fall apart, right? Unfortunately. And so we have actually multiple agents here. First one kind of actually monitoring and triggering when we have any anomalies in terms of any issues that we will see in the logs that don't make sense. And we want to then understand what's the cause. So this agent then we passed over to a root cause analysis agent that actually looks at what might be the cause of the issue. Key here is going to root cause analysis. And then not just, finding out what the issue is one way, but then you want to make sure that you want to deploy something that will actually fix that issue. So we have an automated deployment agent that actually implements fixes through CI/CD, and then a reporting agent that summarizes everything that all those agents have done in a way so that we can kind of communicate that to stakeholders. So if you ever use an app and the app goes down, and then you go to like that status at that, whatever, let's say status.microsoft.com, and you find out, what happened? Why was my service down? We want this reporting agent to complete that and communicate that to our stakeholders, users, things like that, based on all of the activity that the other agents have done. So this is a very real world issue. And I encourage anyone after this Microsoft Learn, even building upon that, because I think this is a much needed thing for anyone working in development for sure.
Okay, so now let's talk about the semantic kernel framework. It's like the backbone of our multi-AI agent system. It's an open source toolkit available on GitHub also, which simplifies integrating advanced AI models into your application. So the Semantic Kernel SDK is an open source toolkit designed to help developers integrate advanced AI models, uh, enabling powerful AI-driven functionality with minimum effort. So you can easily organize tasks, remember things through agents, and use AI models to make apps smarter with semantic kernel. You can add some features like understanding languages, automating tasks, or making smart decisions. Now let's look about at Azure AI Agent. It is the integral part of semantic kernel. First are agents. They are like smart assistants. They understand your input, think through problem, and do tasks on their own, like answering Q&A or automating work. Second are about agent collaboration, teamwork. Agents can work together, like sharing information to handle big tasks, like a group splitting up work to get things done faster. Third is kernel. This act as a brain of the system. It orchestrates of AI tasks, run them in the right order, and manages memory to keep everything running seamlessly. Next are tools and plugins. They give agents extra power like getting data from Bing or running special features to handle different tasks. Also, tools like file retrieval, code execution, or open API integrations provide specialized functionality to handle diverse tasks. And last are history, memory. Agents can save and remember past chats. This allows them to maintain context, track previous conversation, and deliver responses that are most relevant and personalized. That also enhances the user experience. Now let's talk about different types of agents in semantic kernel. Each one is defined for specific jobs, making it easy to build a powerful multi-AI agent system. There are three types of agents. First are Azure AI agent, chat completion agent, and lastly the OpenAI assistant agent. Let's talk about firstly about Azure AI agent. They are great for complex conversation. It works like tools like Bing or Azure functions and keep tracks of chat easily and securely. Next are chat completion agent, which are perfect for chatbot. It understands your languages and keep conversations run smoothly and neutral. And it's also like a more of a natural way of conversing. And last are about OpenAI Assistant Agent, which are designed for detailed multi-step tasks. They can handle and process that require breaking down complex problems into manageable steps, such as planning, data analysis, or task animation.
Nice. So that was a really great way to explain, one agent, right? And particularly the type of agents that we have. But when we talk about, this is the session about orchestrating multi-agents, and I love this word orchestrate. It's all about, as an like a conductor, they always like doing these hands and they point to like one section and then the other one.
Mhm.
And one of the ways that we could do this as developers of agents is through the agent selection strategy. So again, we have the scenario in terms of choosing what agent, or basically these agents are tackling this IT issues or system issues, and we need to be able to find out which agent to route those that requests to or information to. So the first reason why we have agent selection is to make sure that the responses are accurate. Like, we don't want to give an agent that is responsible for looking at logs and analyzing those logs the same to the DevOps agent that's actually looking to fix those logs, right? Well, large language models can be openly applied into different tasks. What you'll see in the code when you're building this in the Learn Live is that we are in the Microsoft the Learn module is that we're actually giving specific instructions to the agent to be kind of specialized on that specific task, so that we want to make sure that we're selecting the right agent for the right job, essentially. The other one is really sort of processing all this information. So again, if we have if anyone's looked at like system design before or anything like that, right, we want to build a lot of efficiencies so that again the right agent has all the information that it needs. So again, we're also going to look at things like plugins and tools and what those require. And then lastly, when we're talking about applying this to bigger issues, right, bringing this to production, bringing this into solving real world problems, we wanted to have a scalable framework, right? That we might get tons of issues in one day. Like, let's say, for example, we have like a Black Friday or an e-commerce store, and we're gonna get tons of traffic that one day, and systems might go down in different places. So we want to make sure that we have a good agent selection framework that can kind of cover all those different grounds and all those different scenarios by still choosing the right agent, even though we might have a larger diversity and a larger number of problems coming out. So how does this all kind of work out? And the first step is actually recognizing the intent of the user and the intent of the information, right? So users will come in, they might ask for, let's say you're running an e-commerce shop again. They might want to buy items, they might want to return items, they might want to cancel orders. And we want to make sure that agents are able to recognize the intent of the user to make sure that is correctly where the agent is being routed to. We want to then also, in terms of being able to like design those rules, we want to give, semantic kernel gives the agent, the power of the developers to define those rules in a custom way, which we'll look at later on when we define our agent selection process. So that again, we're not, caught up into rigid rules and making sure that, oh yeah, some new scenario came out and we won't be able to answer that. And then on the context tracking, right? Shiva mentioned earlier history, and history is rather important here because as the context grows, users are interacting with agents. Then we have a stream of both what the user is responding with, but also the agent responses, the tools responses, and we want to make sure we have all that in context because the next step, whatever is the next agent or the next, the termination, which we'll talk about later on, it's going to matter in terms of what context or what's the next step in there. So we need to make sure we manage that context and track it throughout that sort of interaction. And then lastly, it's dynamic agent switching, which is, again, in certain cases, we might have a very clean sequential step, this agent first, next agent the next. But in terms of other scenarios where agents might have to join, which we'll talk about later, a group chat and contribute that way, we want to be able to do that dynamically based on the context of, again, the responses from other agents, responses from the users, responses from the tools. So within the semantic kernel framework, we have all that sort of built in as a agent selection process.
Okay, so now let's talk about how we can stop conversation or tasks in multi-AI agent system. This is important task to keep things efficient and user-friendly. So a termination strategy ensures conversations end appropriately, avoiding unnecessary messages, and it helps in enhancing efficiency and user satisfaction. Developers can use ready-made strategies or set a limit on how many messages can happen. Without this, agents might keep going when they don't need to, which leads to wasting time or annoying user, and that can also excuse the cost of your resources. In the semantic kernel framework, termination strategies are designed to provide clear endpoints, making interaction more powerful and streamlined. Now, let's look at a practical example of a termination strategy. Imagine a scenario where an agent is tasked with approving a document copy. The termination strategy involves structuring prompts to check if the approval process is complete. For example, like confirming a final sign-off. By leveraging chat history, the agent should track the progress of the conversation. Like the whole chat should be processed through the agent, ensuring it only continues if further input is required. Once the task is finished, the strategy stops the conversation to avoid extra messaging. Hence, we can leverage the use of termination strategy in our code.
So now we're actually going to get hands-on and look at some of this code. I'm going to walk you through exactly all the things that we touched on here, but through the actual exercise that's a part of this Microsoft Learn module. And what we mentioned again, to step back, we have the scenario, the scenario where we actually need to manage the IT services, and we have multiple agents to sort of do that. So if you want, I can go ahead and share my screen.
Let me just unscreen. Yeah.
So the actual when you do this Microsoft Learn module, you're actually going to collect to the Cloud Shell, and thing is, your Cloud Shell will expire after a while in terms of if you don't do anything, and that literally just disconnected right when I was ready to share my screen here. But I will show you the code to kind of actually show you what's going on and how we sort of apply what we just talked about here, the agent selection strategy and the termination strategy as well. So we have, first is defining the agent's instructions, within the prompts, because, again, each agent has their own specific task. We want to make sure to be very clear with our instructions on there. So we want to, and like in this case, we have the incident manager that's responsible for analyzing a given log file or the response of the DevOps assistant. And it should be able to take certain actions, whether that's restart a service, rollback transactions, redeploy resource, or increase quota. So we're giving it options here. And that's a big part of defining a good agent, is to have very clear outlines. And then we also want to make sure we have some clear rules, right? In terms of, either adding a file, read the log file over every turn, so that, again, it's not, repeating itself. And then we have the DevOps assistant. So this is going to be reading the instructions from the incident manager and applying the appropriate resolution functions based on that. So in case here, it's going to return the function as a function response, and basically say, oh, whatever the incident manager says to be done, then I'm going to do that, and then return back that basically the response there. And then also it's going to add the log files and have DevOps assistant be included there. And then when we go down to actually defining these sorts of things, one way you're actually going to be doing when you do this Microsoft Learn module is also using the Azure AI Agent Service. So you'll be adding your project settings and creating the agent through that. And then we basically are defining different agents here, whether that's the agent, the incident agent. So this is the definition. So we get the actual basically the instructions there, and then also any plugins. So one of the things, if you use Semantic Kernel outside of the agentic framework, the plugins was a major financial point about using Semantic Kernel. So this is also where the plugin will be. So this is basically like a tool, if you're familiar with tool calling. And then again, we have this DevOps definition, which is the agent there. And now we're basically going to make the group chat. So this is where basically the agents are going to coordinate with each other, which is the agent group chat. We're going to basically add both of those agents there. And what Hachiba mentioned, right, is this termination strategy. So this is, again, is when we want the approval for when the iterations between the agents, so them coordinating, stops. So first we can decide, which agent is responsible for that. So the agent incident. Then we can have a maximum iteration. So this is basically turning taking the different turns there, and then whenever we want any sort of reset as well. And then what I had mentioned before is then the selection strategy, which is, again, choosing which agents are available for selection, and then how they should be selected. So we don't define that here, but we actually define it through this class. So this class for selection strategy. And in this case, basically what we've defined, and this is bringing it all home now, when we're talking about the history and what's important, is that the incident manager should go after the user or the DevOps assistant, right? So what's this basically saying is just an if statement to check what, who has responded last, and whether that's the incident manager's turn or not. So that's one way to do it. You can actually do this through prompts as well. But this is one way to make sure that the sequence or the selection is working correctly with your scenario, essentially. And then lastly is this approval termination strategy. And this, again, is what Shivan had mentioned. It's one of the strategy to determine when we should actually terminate these sorts of things. And in this case, we're going to check if the agent should terminate. And whenever this return is no action needed, so basically when either the DevOps agent has resolved an issue and now it's no action needed, or when there's no action needed based on the logs, right? It's going to read the logs, say, is there anything for me to do? No? Okay, terminate. And that's basically applying both the selection strategy and the termination strategy as well. There is some other things you can kind of look in the code in terms of the DevOps plugin, and this is literally how you allow the DevOps agent to do its sort of things, basically, whether that's looking at the log entries. So this is kind of a description of what that would look like, and then deciding whether that's to restart the service. So this is a function, roll back to transactions, or even redeploy a resource, for example. So these are just scenarios. And again, what I would encourage you people to do is, do the Microsoft Learn module, and then look at this code and see how you'll be able to adapt this or build upon it in different scenarios. Because essentially what you'll see in the terminal as you run this is basically the incident manager reading the logs, and then the DevOps agent deciding if there's any steps for it to take, and then they're going on to the next log and to the next one. So this is how you sort of apply both the concepts that we just explained, the termination strategy and the selection strategy, in a way that you can have these agents coordinate and basically, like I said, do the jobs that they're meant to do really well, which is either defining incidents or solving those incidents. So if we go back to the presentation, I'll share the screen.
Yeah. So yeah.
All right. So we covered a lot of different things today, and now we're going to play a little game, little knowledge check. See how if we've done a good job, Shivam, right? Because obviously we're responsible here. If no one's answering the right questions, but and also if we know what we're talking about too, I guess. So let's see the first question, and hopefully we've got this in the right order. So I'll read the question, Shivam, and I want you to walk us through the options, and then for people at home.
Okay, let me read the question. Yeah.
Okay.
So first question says like, how does the semantic kernel agent framework select the right agent for a task? That's I guess that's my topic only that I have spoken about.
Right. So by random selection, which sounds like a really good time, I think if we were deploying agents, random selection, which you could do that. That could be a fun app.
Yeah, you can.
Yeah, you can. Not for anything serious, but so
not
random selection,
optimized, I guess.
Yeah,
but
not.
Let's see.
Optimize for fun, Shivam. We can optimize for fun. B, based on the user's intent and predefined rules, which sounds reasonable. Or C, the agent's physical location, which I guess that is where they're located and deployed on Azure. Hopefully, yeah, we get a lot of B's in the chat. Way too many B's. Nobody is even taking a stab.
No A, no C. Chat.
No A, not even like a funny one. Normally someone's
all
trying
are
to be
serious
funny.
right now. Like only B.
Yeah, very serious chat today. And a good evening, which thank you, CV Plus. So yes, sorry. Go ahead and reveal the correct answer.
Okay, so that's the right answer only. It's basically the clear and descriptive instruction that helps the model to generate a response that closely matches the user intent or the developer is looking for. So that's the correct answer.
Very nice, everyone. I see A, B, C, and AC. Okay, great.
AC,
you know
okay.
what? Yeah.
Okay.
Oh, D. Someone said D. That was always one. Okay, next question.
Next question. So now, second question. Which statement best provides agent group chat in the semantic kernel agent chat framework? So
I'll read these. So it only supports interaction between agents of the same type. Okay, that's
yeah.
I mean, I see a lot of questions later on about like using other providers and other agents and agent-to-agent communication. So this could be one. B is an abstract class that must be subclass to enable multi-agent interactions. And I like this answer because once people start using the word abstract and class and subclass, it looks like the right answer. Like I could just go ahead and assume it's a very smart answer. So could be that. And then C, it enables interactions between multiple agents and uses strategy-based approaches to manage conversation dynamics. All right. This is going to be confusing.
Now I can see a spam of C.
Yeah, but the thing is, some people, you got to look at the right time because, people watch this live stream. And last answer was B. So I'm not really sure where the cutoff is exactly. So, I mean, we could say it, but I see a lot of C very recently. Yeah, everyone is saying C. Lots of C's. So we're not getting any diversity in.
Not a single A or not a
I mean,
single
look at
B.
B though. Did you really think about B, everybody? Abstract
Why
class,
not B?
subclass, multi-agent
It's
interactions.
it's
That
good
sounds like
only.
a really
Yeah.
smart one. Cool. So let's go ahead and
Now
reveal
let's do
that
it.
answer there.
So yeah, you were correct.
Congrats everyone on that achievement. So most of you are 2 for 2, but here comes a really hard one.
Okay. Now next question. Final question. So third question says, what is the role of the termination strategy in the semantic kernel agent framework? First option says it determines when a conversation or task should end. That should be, I guess so.
It determines
Second,
what I mean, it's in the name, but it defines the flow of a conversation. Also sounds very reasonable. These are all
yeah,
sound reasonable answers. It decides
that
which agent takes the
hmm,
next turn. These are all very reasonable answers. Okay. We got A's. I
now
don't know
is
if there's a C from the other ones, or not. But a lot of A's. 3. Oh, I love how people are like getting really smart, putting like 3A or
they
2C.
are like B, C, A. Just
Yeah, no, what I mean, like they're saying from question 3
A,
is
yeah,
A. I really
the
appreciate that,
final
everyone.
A.
No more
Someone said
confusion.
C.
Yeah, I like that. Thank you for. I mean, I'm always for people exploring options, seeing what's out there. Okay, so termination strategy in semantic kernel, the agentic framework we just spoke about. Shivam had mentioned termination strategy. So oh, there it is. It determines when a conversation or task should end. Perfect. So that is, I think, great performance, everyone. I think everyone got 3 for 3 in most cases, which is
Someone
I'm
got
gonna say
two.
good job for
Oh,
us too, right? We did a
yeah,
great job teaching.
yeah, correct.
All right, what's on the next
So
slides? Perfect. A little bit of summary then. Again, it looks like you grasped a lot of the concepts that we said here. One of the things is to again be really focused on is the agent side of things. So Shivam, I know you mentioned this before, but I guess kind of summarize this. Like, how do we put all this agentic concepts into a nice slide to finish us off?
So the agent selection process can involve random selection, but the most effective approach uses the user's intent and predefined rules, not like a random selection. This ensures tasks are defined by the most suitable agent and optimizing the efficiency, which were the third question, I guess.
Yeah, I think that was And then we mentioned is the termination strategy, right? A lot of times, people once you start getting applying this knowledge and building these applications, you got to start realizing that you want to limit the amount of conversations that your agent has, whether that's for efficiency standpoint, also in terms of cost, right? In terms of your calling LLMs. So the termination strategy, as we mentioned before, we can define this and basically uh, understand when the task has been concluded, defining those rules. And it's really important in terms of managing these type of conversations, right? Because also from a user experience, you want to ask an agent something, and you don't want to have like the agents going back and forth for 20 iterations. And depending again on what they're doing and what functions they're calling and tools and things like that, that could take some time. So wanting to make sure that you limit that scope there and use a proper termination strategy for the right use case, understanding and defining when to terminate, what agent or what rules are defined by that is kind of really important when you're talking about actually applying this and using something like semantic kernel, because this is actually at the end goal, right? We don't want to just use agents for agent's sake, but to complete some sort of task. And the termination strategy as a developer or creator of the agent allows us to sort of be very clear with both the agents and I would say even ourselves when we're talking about developing agents, of what these agents or what this multi-agent solution is actually designed to do. Because if you keep that rather open, you're going to have a lot of issues or unhappy users, and that's never going to be a good thing for sure. Cool. So we are wrapping up here. We did have a Guinness World Record attempt, which I think fully allowed to now say that we hit that in terms of AI skilling for one day. I don't remember the exact number. Someone in the chat or the moderators know that number. You can put it in the chat, and we will say that. But we basically had a skilling competition on the amount of people skilled in one day, I believe. On an AI, we hit that Guinness World Records, but the Skills Fest goes on. The party doesn't end in terms of learning, so make sure to share that success. And like I said, so that's where you're going to you can redeem your event badge, which you can do there. Use this lovely hashtag AI Skills Fest, and we're running this until the 28th. So again, there'll be new experiences going on, new sessions like this, as well as the sessions of the past. So, again, if this is the first time joining us for all of this, you can definitely go ahead and check that out. And we also have a course called AI Agents for Beginners. It's also using a lot of this very similar content, but we have 10 lessons. So if this is your world in terms of exploring all of the different content out there, in terms of building AI agents, this is 10 lessons, get you started building anything, basically building and deploying AI agents, whether that's using this tool use, kind of the product that we used before, agentic RAG, using agents to essentially go in and retrieve information from databases or data stores and then answer questions, perform tasks. And there's different other patterns in there. And obviously, as we mentioned, the multi-agent pattern, which we discussed today. Thank you, Humphrey. This is why we have moderators. So 126,151 skilled in 24 hours. If you were one of those people, write in the chat. Thank you for contributing to that. And then at the bottom of this link, bottom of the stream, you'll see this link. It's to our Discord community. If you liked hanging out with us and learning, Shivam and I are very active in this Discord. Shivam especially so is very active. He's always answering questions, providing content, helping out the community. And essentially that's what this is a community of learners going in, because all of this stuff is still very new for everybody. So we're always having other sessions within the Discord, community calls directly with our product teams to keep you informed, as well as, again, a great place to get any support, find inspiration. People are building, people are sharing there. So do check us out in the Discord. You can tag Shivam and I there. You can tag.
You can also share your projects over there. We have a specific channel where you can publish or share your projects over there. So
exactly.
we'd love to hear about everything you build.
And you can also tag Shivam and say congratulations there. It's just at Shivam, I forget what your username, but you'll find him. He's a moderator. His name is literally everywhere there. So you'll definitely see his name.
Only Shivam.
Yeah, Shivam. So at Shivam, congrats again for the MVP award there. And I think that's basically it in terms of all of the call to actions that we are presenting here. Is there anything else in the deck there to close out? Of course. There's a thank you. So we'll drop the link. We'll drop the link in the chat. I see people are asking about how to get to the Discord. I'll see you there. But I want to say, Shivam, you all spent 40 minutes with us on the internet. Yeah. You could have been anywhere else in the world right now, but you spent 40 minutes with us. So thank you all for joining us. And if there's any other questions or anything like that, ping us in the Discord, ping us on the chat. We have the moderators still moderating and helping you out with all of that.